Hello everyone, welcome back to my channel. Today let's go over a medium question that I finally solved on my own after some struggling and some trial and error, sort of misunderstanding the question, but at the end I was able to solve it by myself. So again, I'm pretty happy about this, so let's go over it. Basically, you are given this grid and you want to figure out, it's easier to just look at the picture. Basically the X and the Y should have at least 3 cuts. So in this case, 1 to 5 is this, 0 to 2 is this, 3 to 5 is this, and 0 to 4 is here. And then for the Y, same thing, 0 to 2 is 0 to 2, and then 2 to 4 is here, 2 to 3 is here, and then 4 to 5 is here. So it's a little confusing, but once you know that you have to have at least 3 sections, then it's not too bad, and you can trial and error your way towards a solution. But basically now, what we want to do is just get the coordinates I just talked about. So for R and rectangles, let's call this X count and Y count. X count dot append R0 and R2, and then Y count dot append R1 and R3. So let's print X count and Y count. So now you have this, and now we just want to merge them together because we want to see if we can cut them at least 3 times without overlapping, right? This is an overlap, so it's not going to count, but that's just for the X. And then for the Y, so here for the X, we're not going to have 3, but the Y is going to have 3 because we're going to merge these two, and then this is not going to be merged with this because it has to be less than to merge. It has to literally cross. It just because it's on the same plane doesn't mean it's overstepping. So that's another thing to take into account. So now what we can do is we can sort X count and Y count, and let's print them now. So now it's easier to merge. So cool. So now we can merge if, let's say, XX is this for I in range 1 length of X count. So we're just merging if this is less than this. If this is less than the biggest one, it's because we already sorted by the x-axis, so it's going to be x count of 0. And then if x count of I of 0 is less than xx negative 1, then we're going to update xx negative 1 to be the max of xx negative 1, and x count I of 1, which is going to be the original index 2 because it's the end of the x. And now let's print XX just to check our work. X count I of 1, sorry. So that's the x-axis, and then the y-axis we have to do the same. The y count of 0, you can almost just copy this, change this to y count, yy, doing the same merging operation. Okay, that doesn't look right, so I might have messed something up. So I guess we first have to isolate these, which is a pain. Let's just focus on the X for now, because rectangles dot sort t equals lambda x x0 and x2, because we're sorting by this and then this coordinate for the X, and then we have to do the same thing for the Y later. 1, x3, let's see, it's probably not going to be it because we didn't even do the Y count, so now we have to do this here. Y counts R1 and R3. Okay, something doesn't seem right. Oh, otherwise, if it's not overlapping, it's like 0, 2, and 2 and 4 that you just append x count of I, right? Because it's not overlapping, so you have to include it as the latest sublist to the rightmost of the matrix. So now, cool. Now we can just say return length of xx is bigger than or equal to 3, or length of yy is bigger than or equal to 3, because at least 3 cuts. And I found this out through playing around with the test cases a little bit, because it's pretty unclear. But there you go, passes all test cases. So again, just took some trial and error. It was kind of hard to understand the question, but I'm glad I was able to do it in the end on my own. So that's it for this video. Thank you for watching, and stay tuned for more.